Man, nobody even watches my videos. Should I even keep doing this? Maybe, maybe I should just give up and focus on something else. The hell?
Where's your motivation?
You shall die! Hell yeah, guess who's back? I know that I'm far from being first to make it, but I think mine is the best one. And besides, there is almost no tutorials on it, so yeah. Oh, and I should probably say that I'm gonna use Blender today quite a lot. So you better have it downloaded. If you don't know how to use it, don't worry, I'll explain everything. So, before we can start judgment cutting, we need to get Yamato first. For the model, you either make one yourself in Blender or any other modeling software, or just take an already made one from Toolbox or some website. I got myself this one from Toolbox and also removed ribbon because it looks ugly without Smart Bond module. You want to get one with separate sword and sheath, but even if it comes as a single piece, you can still split it in Blender or any other modeling software. I ain't repeating that again. Now, to simplify animating process, let's set up handles for Yamato. Basically, just get two parts and position them where you want your character to grab it. For the sword, it would be the sword handle, and for the sheath, it would be right here. Insert your handles into their respective Yamato parts. Insert a wield constraints inside of your handles. Set part 0 to your handle and part 1 to their respective Yamato part. And to make it actually animatable, insert a motor 6D inside of the sheath handle, save position and orientation of the sword handle somewhere, set part 0 of the motor 6D to sheath handle and part 1 to the sword handle. Subtract current position and orientation of the sword handle from the one that you saved, and put results inside of the motor 6D C0. Now get yourself a dummy you will be animating on, position your Yamato, and insert a motor 6D into the part you want to wield Yamato to. Save sheath handle, position and orientation, set part 0 of the motor 6D to your part and part 1 to the sheath handle. Subtract sheath handle current position and orientation from the one that you saved and put results inside of the motor 6D C0. But if you had Moon Animator, it could have been a little bit easier. So open Easy Build, select your parts and hit Join in Place. For motor 6Ds you want animatable on and for wheel constraints off. But you already knew that. Oh, and if you don't have Moon Animator, there is probably a free version of a builder like this somewhere. You should really get it, it will save you a lot of time. Make sure all of the Yamato parts are uncollidable, unanchored, and also massless. And now let's wield Yamato to the player. Duplicate your Yamato inside of the replicated storage. Insert a script into the server script service. Get players, get replicated storage. Use player added event to connect a function and get player. Use character added event to connect another function and get character. Clone your Yamato, parent it to the character, get the part you want to wield Yamato to, create a new instance motor 6D, set part 0 to the part you want to wield it to, and part 1 to the Yamato sheath handle. And set C0 of the motor 6D to the one on your animation dummy. And of course, set its parent to your wield part. You can make it work for both R6 and R15, you just would need to get a separate wield frames. Now, let's take a look at the animation. The whole thing lasts for 6 seconds, and of course you don't have to remake it one-to-one. But it would really simplify things for you. So, the first thing you see is a bunch of events, the purpose of which I'll explain later. So, the first half a second is taken by taking a stance with the Yamato, and the next second by preparing for the attack. followed by 0.25 seconds of preparing to rush forward with a few keyframes, and another 0.25 seconds of rushing forward. Next second doesn't really matter because the character will be invisible anyway, but the next second it is falling down from the sky at the original position and putting Yamato into the sheath, with another second sliding it down all the way. After that, hold the pose for half a second and return to the starting pose with what's left. For the event timestamps, it's 0.3 for the first one, 1.667 for the second, 1.750 for the third, 1.9 for the fourth, 2.833 for the fifth, 3 for the sixth, 4 for the seventh, and 5 for the eighth. Alright, now we can get to the real thing. Insert a remote event inside of the replicated storage. Insert a local script inside of the starter player scripts. Get a local player. Get replicated storage, remote event, and a local character. Get mouse from the player and use it with button 1 down to connect a function. Get GPE, which is a game processed event, and return if it's true. This will prevent our function from triggering when we use chat or things like this. Now use remote to fire server with our player character, and a server time you get using workspace get server time now. Now insert another script inside of the server script service. Get replicated storage, a remote event, use on server event to connect a function, get player character, a server time we got on a client, and fire all clients with a character. We're gonna return here later because it's kinda boring and I gotta keep viewer retention high, right? So, insert a local script inside of the server script service, get replicated storage, twin service, run service, our remote event, get your audio and animations folder, ignore all of that for now, connect a function using onClient event, get character, and now we can finally get to the effects. First, let's make this expanding sphere. So, we're not gonna use the sphere that Roblox provides, because if you import it in Blender and look at its geometry, you'll see that all of its faces are different lengths, and that's not what we want. Instead, open your Blender, create file General, select all of this, hit the delete button on your keyboard, use middle mouse button to zoom in and out, hold it to look around, and hold shift plus middle button to move around. Now go to Add menu, Mesh, UV Sphere, and also change its properties right here. Just remember your segments value for later. I'm just gonna double it. After that, hit right click and shade smooth to make faces less visible. Now, to export it, go to File, Export, and you want to export it as either OBJ or FBX. I usually prefer FBX, but they both have their upsides. And to import it inside Roblox Studio, just hit Import 3D, select your file and hit Import. Now, we're actually going to use special mesh instead of the mesh part, because it has property called Vertex color that allows us to overflow color values to get brighter colors. So create regular part, set its size to the diameter you want our judgment cut to be, and its shape to ball. Insert special mesh inside of it, copy mesh ID from the sphere that we imported, and set its scale to 0.5 if you import it from FBX, or 25 if from OBJ. It depends on the mesh size. And play with vertex color for a bit till you get the color you want. Mine set to 0.15. Now for the force field effect. So set the material of the sphere to force field, and what you're gonna do is put an image of the cloudy sunset on the mesh. Basically, how the force field works is there is a value that bounces between 0 and 1, and depending on that, part of your image gets visible. based on how much red in there. So like if this value is on 1, then only parts that are completely red are visible. If it's on 0.5, then only those that are half red are visible. You get the point. Also, now that I think of it, maybe to get an animation like this, you could take a time lapse of a cloudy sky, split it into frames, and loop through them to get the animation. But I'll leave that up to you. After that, set C frame of your sphere to the C frame of the animating dummy, humanoid root part. Copy Y value of the position for later and set it to 0. Now get a new part and do the same thing, but don't change the Y value. This will be the primary part of our model. So select it and the sphere and group as a model. Set model's primary part to our part. Set the special mesh scale to 0. Put our model inside of the replicated storage. Go back to local script, get local character for later, clone our model and parent it to workspace.effects, which is a folder for effects that you should create. Use pivot 2 with character's primary part C frame to adjust C frame of the whole model instead of just primary part, and use twin service to get the scale of our sphere back to 0.5 or 25. Now let's make this flash you see at the start. So, set the exposure compensation property to 3 to make the world a little brighter, and twin it back to 0. Insert an attachment into the primary part and set its Y position to 0. Insert a particle emitter inside of it, and we finally go to the particles. So, let's move from top to bottom. Set light influence to 0, so our particle isn't affected by light. Set orientation to facing camera. For the size, we need to make it go from 0 to whatever the size of our sphere is. And the maximum size you can normally go to is set to 10. And as you can see, it's not nearly enough. To bypass this restriction, you will need to get one of many particle editor plugins, and most of them will give you the ability to go beyond the size of 10. Keep the squash at 0, and to get the texture, you will need to open the toolbox and search for particle pack. Pick one of them and look through its particles till you find the one you want. For the transparency, we need to keep it at 0 till the very end to smooth its disappearance. Z offset is basically renders particles closer or farther to the camera than they are. Useful when you want particle to be in front or behind something. For this one, set it either to 0 or something low like 0.5. This doesn't matter. Emission direction doesn't matter if the emitter placed inside of the attachment. Play with it if you want. Enable to false, because we're only gonna use this emitter with emit. Rate doesn't matter for the same reason. Lifetime to 0.3 or whatever aligns with your animation. Rotation min to minus 360 and 360 max. 180 is enough, but you can go beyond if you want. Rotation speed 0, spread angle 0. Again, emitter shape doesn't matter if it's inside of the attachment. And finally, flipbook. Oh, basically, you have your regular particles that are just a single image. And you have flipbooks that are multiple images that emitter gonna loop through. There are 3 types of flipbooks that are just 2x2, 4x4, and 8x8 grids. And looks like there's actually a new one called custom that by the looks of it allows you to make your own grid sizes. Modes are a loop that loops all the images forever with a set frame rate. One-shot stretched flipbook for the whole duration of the particle's lifetime. Ping pong is like a loop, except when it hits the last frame, it plays it again in reverse. And random just shows one of the images with a selected frame rate. For this one, keep it at one shot. Flipbook start random, randomly chooses one of the images to start from. We don't need this here. Keep the rest at default. And for the second, I'm going to be using just a single image. And as you can see, it doesn't follow camera, but stays in one place. To achieve this, we need to set the orientation to velocity perpendicular, because velocity parallel has been broken for a very long time, so don't expect a fix anytime soon. And set speed to 0.001, so there is a velocity that particle can align to, but not enough to actually move it. Next is all of that debris. Create a new part, set its C-frame to the one of our sphere, set its size to your sphere diameter, make it flat, like this, and insert a particle emitter inside of it. Get an image of a rock for texture, make it face camera, don't make it too bright, make it very little, set emission direction to top, rate to something big, and lifetime to whatever you want. Randomize its rotation, increase speed, set shape to disk, shape in out to outward, shape partition to 1, and shape style to surface. You can also add some drag to slow down particle speed towards the end of its lifetime. After that, copy your emitter, insert it inside an attachment, lower rate a bit, and increase spread angle so our particles come out in a cone like this. Rotate attachment 5 more degrees than your spread angle, like this. Duplicate your attachment and arrange them like this with a total of 16 attachments. To make this easier, you can also press Alt plus D to enable attachment visibility and Ctrl L to switch from local axis to world axis. Now, what we're gonna do is spin this part so it creates a tornado effect like this. But before we do this, there is something very important I must explain. In Roblox, there is a graphics quality setting. It's this slider. And values ranging from 1 to 10. These values affect many things, including particle emitters. To be specific, it affects the rate property. So, if you made your particles for the graphic value of 10, and then switch to 1, there will be significantly less particles than you intended. To fix this, you need to go through every particle emitter that works with enabled property, set to true, and multiply its rate by your desired graphic level, and then divide by user's graphic settings that you can get through user settings, game settings, save at quality level .value. Now, if user changes his graphics settings after emitter was adjusted, it won't automatically readjust itself, thus causing some problems. We can technically fix this with a loop using run service, but it's going to be very performance heavy and just unnecessary. Like, how often do you change your graphic settings mid-combat? Just keep that in mind and try not to use this on emitters that last very long. Okay, so emit our particles and back to our debris. Create a coroutine so it doesn't stall the script while we spin it, and use twin service to adjust the frame of your debris part with cframe.angles. And don't forget math.rad for the proper angle conversion. Make sure it spins in the right direction and spins for a little longer than our sphere will be present. After that, just use coroutine resume to continue script execution. Now let's make this vortex. So, I took this half sphere. I didn't want to make it fully black, so I set color to white and light emission to -3 to make the texture thicker and darker. For the size, make it go from max to 0. Skip ahead a little bit and set rotation speed to something high in any direction you want. You can also go above limit here if you want. Now go back to squash and adjust it a little bit across the timeline to make sharp ends of our particle less visible, like this. And now onto another bug. You see, for some reason, if you leave your emitter like this and try to spin it, which you probably figured out we're gonna do, its behavior becomes very inconsistent. I'm not sure why this happens, but I know how to fix this. All you gotta do is set spread angle to something above 0 like this. And as you can see, some particles get flipped for some reason. And this is kind of what we need, but there's still more unflipped particles than flipped. So duplicate your particle meter and split the rate of each one in half. Then just flip the image like this for the second emitter. But to do this, we first need to download our image. To do this, you can either use better Roblox Chrome extension that will allow you to download it with a single press of a button, or right click and select View Code. This will open an admin panel in which you need to find the URL of your image like this. I won't show you how to do this, because I'm pretty sure there's a chance of me doxing myself if I do, but I think you can figure it on your own. Set lock to part to false on both emitters and we can go further. So, adjust rate of our vortex, as I have already shown, and make it spin just like our debris. Although maybe a little bit slower. Just find the speed you like. Next is this electricity effect on the sheath. So, get a bar like this, and scale it to the size of the sheath like this. Make it invisible and build it to the sheath. Now, the general rule of thumb for making good electricity effects is a very small lifetime with a big rate. So, do exactly that. Make it bright, set light emission to 1, and also, instead of a single color, you can make a gradient. To do this, just click on these dots and make a gradient with colors you want. Set size to something a little bit bigger than sheath width. Set transparency to 0. Randomize rotation. Make sure lock to part is set to true. Now, for the texture when making electricity, it's almost always better to go for flipbooks. So, get your flipbook and set it to one shot. Now, to add some variety, duplicate your emitter and change the texture to another one. I did this 3 times. After that, just adjust your emitters and enable them. Now, let's make this fire aura. Grab a part and set its C-frame to that of our character lower torso. Or just torso if you're working with R6. Scale it something like this. If you need to offset it, but remember by how much you offset it, insert a particle emitter. For the texture, I will be using this smoke one instead of fire because I can. Make it bright. Set light emission to something a bit lower than 1, so it stands out a bit more from other effects. For the size, I think it's pretty obvious. For the transparency, make it smoothly appear, say like this for a moment, and then slowly fade away. The offset is up to you. Set lifetime to something around 1 second. Rate to whatever covers your whole character. Randomize rotation and also rotation speed. Don't make it too fast though. Now, make sure emission direction is set to top and increase speed a bit so particles go up just like a real fire. It's not too noticeable, but in the end it adds up. After that, just set lock to part to false for a real cool effect later. To finish our aura, copy electricity emitters from the sheath and paste them here. And just make them a bit bigger. Like this. Put it inside of the replicated storage, clone it, parent it to our model, create a new instance wield inside of it, set its C-frame to lower torso, offset if you need, set wield part 0 to our aura and part 1 to character's lower torso. And of course, adjust fire emitter's rate. Also, this is where you play your animation and sound to which we'll get later. I'll be honest, I have no idea how to preload the animation right now, so the first time you play it, it's gonna look off. I'll make a loading screen tutorial in the next video that should fix this issue. Finally, we can get to our events. First one happens when our sphere fully expands and enables waves and firing. Let's do it first. Remember how I said to remember the number of segments of a sphere we taken from Blender? Well, pull it out right now. What we need to do is calculate the length of a single segment. I'm gonna be honest, I have no idea how to do that. But luckily for us, we got all kinds of calculators at our disposal. The one that we are looking for is Polygon Calculator. I'm going to use this website with ads that none of my 3 ad blockers can detect. Now, you would need to specify the number of sides our polygon has, which is equal to segments property we set in Blender. After that, you want to choose the option to calculate with circumradius or just radius. For me, it's 50 because 100 divided by 2 is 50. After you got your radius, just click calculate and copy your side length. Create a new part and make one of its sides as big as the side length we just got. Now, before we continue, first we need to make fire emitter itself. So, insert attachment in this part and emitter inside attachment. Set brightness to 10, light emission to 1, orientation to velocity perpendicular, speed to 0.001, smooth its appearance. And now for the texture, we need a cubical file like this. I wasn't able to find a flipbook like this anywhere, so I made my own. Now, I will show you how you can do the same. Just to make sure, I'm not gonna do it from scratch, because I don't know how. What I'm gonna do is take a GIF that I found on Google, use a specialized website to split it into frames, download archive with your frames. Now, your frames have to be the same size vertically and horizontally. If they are not, you would have to resize them. You can achieve this with any website of your choice. I'd personally recommend this one. We're gonna use it again soon, by the way. Now, if you have 4 frames, choose 2x2 grid, if 16, 4x4, and if 64, 8x8. If you have any other amount of frames, choose custom. And also it won't work if you have more than 4096 frames. And in that case, just pick another GIF, bro. Also, it would be much better if you had an even number of frames. So, now you need to find so-called texture packer. I'm gonna use this one. When you're inside your texture packer, first divide the amount of your frames by 2. So if you had, let's say, 42 frames, you would get 21. Now let's say your frames are 512 by 512 pixels, so multiply 512 by 21, and in that case set size of your canvas to 10,752 by 10,752. Although I hope you understand that the textures of this size are gonna cause some trouble. I recommend to go for the size of 2048 and lower. Okay, now disable trimming, don't allow rotation, and set padding to 0. It can have different names in different texture packers. After that, you would grab all of your frames and drag them here like this. Now, by default, it will sort them by name. So you maybe have to do some tricks like I did here with an A to make sure every frame is where it has to be. And if you did everything correctly, it should look something like this. Also, some texture packers like that one this guy recommended can leave a gap here and here, like this. If that happens, just switch to another texture packer. But if everything is fine, export your canvas and upload it to Roblox as our texture. Set flipbook mode to loop. If you chose custom flipbook layout, here is where you change the grid for it. Make sure the particle is exactly as big as part which size we set using Polygon Calculator. If it gets too low or too high for your liking, you can use Squash to balance it out. And next on the line we have yet another bug. So, if you look at our texture right now, from a far away or from a side, you can see this little line on top of the texture. Now, it actually happens to all particles to some extent. Basically, what happens is Studio takes pixels from the bottom of the image and puts them on top. And the best fix I can offer is just slice some pixels of the bottom of each frame. It won't completely fix it, but it would make it better. To finally make our file ring, put our attachment inside of the replicated storage. Don't forget to disable it. Use for I equals 1. Put your sphere segments number to make a loop that will run amount of times equal to what you specified here. Clone our attachment. Duplicate primary part of our judgment cut. Remove everything inside of it. Parent our attachment to it and just set its cframe to cframe.angles math.rad I, that is the current amount of times loop has been fired, multiplied by 360 and divided by amount of segments plus the half of exterior angle you got from polygon calculator, multiplied by cframe.new with your sphere radius. After that, run the game, go to your FX folder, and cut the attachments, go back, paste them into the copy of primary part like this. Connect a function to animation event using getMarkerReached Put the name of your event here. Loop through all of the descendants of the primary part copy. Check if it is a particle emitter, and if so, use emit to emit a single particle. Now let's do this 3D wave effect. It's actually not as easy as you might think. First, open a Blender, create a new file, delete all of this, go to Add, Mesh, and select a cylinder. Select it and press S to rescale it. Use X, Y, or Z to lock rescaling to a single axis. Currently you need Z. After that, press Tab to enter edit mode. Select face editing mode right here. Select the top face and delete it using delete button. After that, go back to the vertices editing mode. Hold Alt and click between the vertices like this to select the whole ring. Press E to extrude and S afterward to rescale extrusion like this. Do it a couple of times, depending on how many waves you want. When you're done, select central ring, press M to merge and pick Add Center. Now select rings one by one, press G, use XYZ to select needed axis and move them up and down a little bit like this. You can also smooth your waves using Ctrl B, but don't get too excited. You still want some optimization in your game, right? After you're done, export your model like I have already explained. Import it to Studio, center it to our judgment cut, rescale it to be a little smaller than our sphere, lower it down as much as you can with all of the waves being on the top side. Disable collisions, anchor it, make it transparent, blah blah blah. And here comes the not fun at all part. If you didn't figure this out yet, what we're doing here is getting multiple rescale copies of a single image and looping through them to create illusion of it moving. So, get a suitable image, like this, open it in web browser and download it. And what you want to do now is rescale the image without rescaling the canvas. You can do it any way you want, but I will show you how I did it with a couple of websites. First, I used bulk resize photos, so drag and drop your image, and now you gotta rescale it by percentage. So first, choose the offset by which you will be decreasing image size every time. I chose 5%, so 100 minus 5 equals 95. Set image format to PNG and make sure you preserve transparency. Download your rescaled image. And as you can see, resolution went down from 420 by 420 to 399 by 399. So we just need to bring it back to 120. To do that, I'm going to use PNG canvas size changer from online PNG tools. So, upload your image, select the desired width and length, make sure your image is centered inside the canvas, change the background to nothing, and as you can see, it became a bit smaller. Now you just have to do this like 30 more times. By the end of this fun activity, you should end up with rescaled images ranging from 100 to 5%, depending on your offset. Now, if your 100% image does not cover the whole wave mesh, you can also do the same thing in the different direction like I did and go to 140%. Now just arrange your images in a table going from the biggest to smallest. Here is my table. If you for some reason don't want to make your own, go back to our wave mesh and insert a number of decals equal to the number of waves you want here to be at the same time. I'll do 4. Assign 4 locals with different numbers equal to the image each wave will be starting at. Create a new function, set each decal to the texture equal to its corresponding local. Add 1 to each local and check if local is bigger than amount of images you put in the table. And if so, set local to 1. And bind your function to render step using run service. To do that, just assign a name to this bind, set render priority to camera, render priority -1, and put your function name here. Let's move to the second event. This one happens when we begin to dash forward. So, set exposure compensation to 3 and twin it back to 0. Disable electricity emitters inside of the Yamato and enable electricity emitters inside of our aura. Go back to our primary part and insert another attachment. Put a particle emitter inside of it. Set brightness to 1, orientation to velocity parallel. It's actually useful here. Make size a curve like this, increase squash to something like 0.3 and increase envelope to 0.5. For the texture I'm using this kinda gunfire flipbook. Set lifetime to something like 0.25, rotate it if you need, set min and max speed to something like that, set spread angle to something around 30 on X and about 55 on Y axis. Make it one shot, and it also will be good if you add some drag. Rotate your attachment to the front by amount equal to what you put in X axis, spread angle, to get the effect like this. After that, you can check the color of the part character is standing at. To do that, just fire array downward from primary part. Don't forget to exclude the character. Check if ray hits something, and if so, set the color of particle emitter to color sequence.new result.instance.color. And finally just emit some particles. Next thing is this after image and sheath flash. To do that, get all of the descendants of character, check if it is a base part, if its name isn't equal to collision part and humanoid root part, and this is a part for your own invisible parts attached to your character. So to not have any trouble with them, just go to your part, scroll down to tags and add a new tag called invisible. After all of these checks, clone your part, parent it to workspace.fx, clear all of its children, set its color to light blue or whatever you want to be honest, change its material to neon, transparency to 0.5, anchor it, disable can collide, check if a part is a mesh part, and if it is, set its texture ID to nothing like this. Now pull out your Yamato again, insert an attachment inside of the sheath, position it at the very end of the sheath, insert a particle emitter inside of it, set brightness to something like 10, light emission to 1, orientation facing camera. You can probably just make size go from 0 to 10, but mine looks better with this bump for some reason. Squash from 0 to 3. For the texture I'm using this shining star thing. Now set Z offset to something like 2, so it's visible from most of the sides. Set its lifetime to 0.2, rotate it like this, duplicate your emitter, and add about 10 degrees to rotation, and then do it again to get something like this. Now insert another emitter, get yourself a texture like this. Brightness to 10, light emission to 1, facing camera, make size go from 0 to 10 or a little less, keep squash on 0 for the half of the timeline and then bring it down to -3. Set lifetime to 0.25 so it's longer than the rest of emitters. Check if the name of the clone is Sheath, and if so, clone the attachment, parent it to the clone, emit a particle from each emitter, create a new instance point light inside of the attachment, make it blue, set brightness to 40, range around 15, and use game.debris to delete it after 0.1 second, and to delete clone after 0.233 seconds. That's the time until the fourth event. Before we get to the third event, assign current camera for later. So, the third event will make our character invisible and make 3 RGB clones of it. To do that, get the right vector of the camera C-frame, loop through the descendants of character, make the same checks we did on the previous event, use twin service to make original part transparent in 0.25 seconds. It's the time right when dash ends, clone the original part, parent it to workspace.fx, clear all of its children, make it fully red, set its material to neon, transparency to 0.5, make sure it's unanchored and uncollidable. Check if a part is a mesh part, and if so, set the texture ID to nothing. Use game.debris to delete it after 0.15 seconds, the time until the fourth event. Set clone position to clone cframe.position plus camera vector multiplied by the position of set. Create a new instance wield constraint inside of the clone. Set part 0 of our wield to our clone and part 1 to character's lower torso. And use game.debris to delete the wield as well. Duplicate this part of the code, change the color to green, delete this line where we change its position, duplicate it again, change the color to blue, and replace plus with a minus here to offset it in the opposite direction. Make another check for the original part, if it is a decal, to also make it transparent. Phew, we finally got to the most interesting part. Fourth event will handle all of the slashes and debris. But before that, we need to assign some locals outside of the event function. One empty local to hold our debris, one bool one to turn on and off Q shift, an empty table, and another one to store the current offset, along with 2 models for the effect. Alright, now let's get to the fourth event. Set the parent of our judgment card end to nil. Yeah, I tried destroy, it doesn't work for some reason. So nil is officially superior. Unbind our waves function from render step. Close our coroutines, just in case, because I'm not sure that they close automatically. Play the second part of the audio here, like I said, we will get to that. Give a name to our models, parent them to workspace.fx, create a new instance highlight inside of the second effect folder and disable it. I'll explain later why we need it. For now, let's make our debris. So, create a new model inside of the workspace.fx, name it, create a new instance part inside of this model, set its C-frame to our character's primary part C-frame, anchor it, make it uncollidable, and set the primary part of our model to the part we just made. Use for I equals 1 loop, put the total amount of debris particles you want here. And before you start asking why we're using parts this time instead of the emitter, I'll explain that the reason lies in the fact that we are going to make this glass effect a bit later. And glass material that we are gonna use does not support particle emitters. Like, if you put one behind glass, it just won't render it. So you might think that we can just grab a part, make it invisible, put a decal on it, and be happy with ourselves. But again, glass material doesn't support transparency whatsoever. So, grab a part, make it your desired size, squash it like so, put a decal on each side, put your debris texture on one side, and for the other side, you will have to mirror it. Hopefully you know how to do that. Now export this contraption, and let's head to the Blender with me. Delete all of that, import your debris, right click, set origin, geometry to origin, press tab to edit our debris sandwich, click on one of the images, press Ctrl L to select all connected vertices, click on the second one while holding shift, and press Ctrl L again. Press P P to separate by selection. Deselect our images real quick, change editing mode to edges, select these two, press delete and select dissolve edges. If this happens, open this tab and uncheck everything here. Use axis control to lock yourself in a view like this. Hold Z to change viewing mode to material preview. Press K and cut around our image like this. Try your best to limit the amount of cuts because there will be a lot of these things. After you're done, press enter, Ctrl I to invert the selection and delete it. Press A to select everything and E to extrude it. And it should automatically align it by normal. Open Settings tab and extrude it by 0.001. Now you can delete the images and export your debris. Import it in Studio as a mesh part. Put your decals on it and adjust its color to match your decals as much as possible. And as you can see, it works just as it should. One more thing we have to do with our debris is change its mass so we can slow its fall later more easily. To do that, enable custom physical properties and change its density until you get your desired mass. Try to make it more than 0 but not too big. I recommend to go with 0.005 like I did. So, put your debris mesh inside of the replicated storage. Clone it, get a random number from 0 to 1, multiply it by 2, and then multiply it by math.py. Get a square root of another random number from 0 to 1, and multiply it by the maximum distance you want your debris to end up starting from the sphere center. Well, technically, it's at the character's primary part, but we're gonna set y coordinate manually, so it doesn't matter. After that, you're gonna multiply second number by the sine and cosine of the first, and that will be your z and x offset respectively. Now, could have we just used math.random to get the number from -45 to 45? No, because if we did that, we would get a cube instead of the cylinder that we are looking for. So, set the debris position to character's primary part position, plus vector3.new, with offset x, a random number from -2.169, which is one star above the actual center of the sphere, so that debris doesn't touch the ground when it spawns, and offset z. Set debris rotation to vector3.new, math.random, -180, 180. Set debris parent to debris model. Run the playtest, go to the effects folder, cut the debris model, put it inside of the replicated storage. Clone it, parent it to workspace.fx, and use pivot 2 with the character's primary part to align all of the debris positions. And now let's finally make judgment cuts themselves. So, get yourself a part and scale it to 0.1. This would be our main judgment cut. But if you were paying close attention, you probably also noticed it split into red, green and blue here for a second. So to do that, just duplicate your judgment cut, move it a bit to left and make it red. Duplicate it again, move it to the right this time, make it blue, and for the green, just duplicate your cut and make it green. Group all of them together as a model and toss straight to replicated storage. Go back to script. Create a new local function, clone our judgment cut, check if hue shift is equal to true, and if so, set the transparency of main judgment cut to 1 and all of the others to 0. Type color3.new and pick two colors just like this. For me, it would be light blue and purple. So basically, what we are doing is changing judgment cut color to a random one between these two. You probably assume that we can just use math.random as usual, because you clearly just saw me use it to get a random number between 0 and 1. And yet, if you were to specify more exact range for picking a number that would be smaller than 1, it would always just return 0. So, what we actually need to do is assign a local with random.new and use it with next number to get our desired randomness range. So set judgment color to color3.new, your local, next number, take the first lowest number out of these two, comma, and put the second number. And do that for every number that differs between those two. And now probably the hardest part there is, where we gonna use math to calculate position, rotation, and size of our our judgment cut. Basically, what we need to do is generate a random chord inside of our sphere. To do that, first we get a random direction and normalize it with .unit. Then multiply it by sphere radius, add and subtract it from sphere center to get 2 points on the sphere surface, going through the sphere center. After that, get a random position inside of the sphere. To do that, we are going to use a bit modified formula from here. So, get a random number from 0 to 1, multiply it by 2 and pi. Now, get arc cosine of a random number from -1 to 1, which is basically an inverse cosine. Get a cubical root like this from a random number from 0 to 1 and multiply it by sphere radius. Now this radius should always be less than sphere actual radius, and the closer you get to the actual radius, the smaller cuts can get. So try to find balance. Now just get all of the exits like this and get the offset by adding all of these to sphere center. Get half of the chord we need by subtracting point A from point B and dividing by 2. Get another set of points by subtracting and adding our half a chord from offset position. Get a direction from sphere center to both points, multiply it by sphere radius, and add it to sphere center to get the last 2 points of our chord. Now combine those 2 different points to create our chord position. To get the chord length, you just subtract our points from each other and use dot magnitude. Finally, twin all of our judgment cuts size to 0.1, 0.1 chord length. Set the C-frame of our cut to the chord position. Set its C-frame to C-frame.look@, judgment cut.position, and one of your points. That will basically keep the position of our cut and make it look towards the point you specified. Set the red judgment cut C-frame to our main judgment cut C-frame, multiplied by C-frame.new, offset 0, 0. Green one to just our main judgment cut, and blue to our main judgment cut C-frame multiplied by C-frame.new minus offset 0, 0. And set our judgment cut parent to the first FX folder. And for glass we are going to use a little bit different approach. So get distance from offset to sphere center. You can use the old offset to save some processing power. Get direction from offset to sphere center and use cross on it with a vector 3.y axis, which is an equivalent to this, which is basically walled up direction. Normalize it and use cross on the direction again with the tangent we just got. Calculate our half chord vector by getting a square root from distance multiplied by distance subtracted from sphere radius multiplied by sphere radius. Add our second tangent to offset and multiply it by half chord vector to get our point A and subtract to get point B. Get chord position and length the same way we already did. Now allow me to explain how the hell does the glass effect works. Remember how we created the model and added a disabled highlight to it? Well, basically there is the bug that if you add a highlight to a part with a glass material and set transparency to something higher than 1, this will happen. And the bigger the transparency, the more distortion there will be. And for why we had to add a highlight to a model instead of just adding a highlight to each glass part is that there is a limit on how much highlight instances you can have active at a time. But there's some good news. Before it was just 31 active highlights, but while I was making this video, they finally raised the limit to 255. Although it still is a limit, so it's better if you add a highlight to a model. So get yourself a part with a glass material, name it, and put inside replicated storage. Clone it, set its position to chord position, set its C-frame to C-frame.look@, with glass position and one of the points, so that our part looks towards the specified point. Rotate your part by 90 degrees, set its size to vector 3.new, 1, chord length. Parent it to the second effects folder, and set its transparency to something around 3 or whatever you like. You can also use cylinder block type for your glass to get this effect, and if you don't, it will look something like this. Next will be those circular cuts and ground marks. So, the most interesting part about these cuts is probably just making the part itself. So, to do that, we are going to use a plugin called Archimedes. Get yourself a part like this, open Archimedes, pick a direction, angle, and hit render all. You should get a circle like this. Delete half of this circle, and I personally loaded up in Blender to fix all the gaps and polish it just in general, but I'm pretty sure you can just union this if you're fine with that. So, what I want you to do now is to look at your circle size. You need this one. Divide it by 2, grab a part, set its position to your circle position, it's gonna be somewhere like there, and offset it by the value you just got, like this. We need this because if we try to just spin the circle by itself, it's gonna look something like this. So, create RGB copies of your circle and use build constraints to attach them to our part like this. And put it inside of the replicated storage. Clone it, change its color like we already did, check for the hue shift, use the same formula that we use for the debris, swing its rotation like this, run the playtest a couple of times to make sure it's spinning in the right direction, parent it to the first effects folder, and use game.debris to delete it after some time. For the ground marks, what you want to do is open Toolbox and search for VFX packs. You need to find something like this, then find a mesh like this and squish it. Load it up in Blender, cut off the edges like this. Bring it back, make it black, apply some material if you want, clone it, use the same formula, and position it a little bit above the ground. I'm making sure it does not go outside of the sphere just by offsetting its position up to 25 stats and making it not bigger than 50, so it physically can't. Randomly rotate it and parent it to the second effects folder. That will be the end of our function. So close it and use run service to bind our function to render step. Put the name of the bind here. It can be whatever you want. Here put the render priority. Set it right now to the camera priority -1, and here put your actual function. Next, you need to create a hitbox inside of our sphere to check for all of the characters inside of it. So create a new overlap params, set the filter type to exclude your character, map and effects folders, use workspace get parts and radius with the sphere center position and the radius of the sphere and our param. Create a new empty table, loop through the output of our hitbox, check if the detected part has a parent, check if the parent of the detected part has a child that is a humanoid, and check if the parent of the part isn't inside of our table. Add the parent of our part to the table, and now you can do one of two things. You can either play a random animation like one of these, or what you probably should do is just stop all of the animation that currently playing on the animator of the humanoid. You can do this like this. It will look very cool if you do that. Now check if the local character is inside of the sphere. You can use whatever method you want, but I'll use distance check. And if local character is inside of the sphere, put it inside of the table we prepared and set it to true. Now let's make the glass effect that follows the camera. To do that, create an empty table, use for loop, clone your glass again, get a random X and Y frame axis, set the Z axis to something like -10, get a new random angle, set the size to something like this, parent our glass to the second effects folder, set its transparency to 2. I don't recommend going higher, it doesn't look that good. Now set two attributes of the glass with your C-frame and angle, insert your glass inside of your table, Create a new function, loop through the glass table, get all of your attributes, and set glass C-frame to camera C-frame multiplied by C-frame and angle you got from attributes. Bind your function to render step, but this time don't subtract 1 from the render priority. Now, if you don't have bloom and color correction inside of your lightning tab, add them. Preferably set them to these values. Go back to script, set bloom intensity to 10 and threshold to 0.8. Twin lightning brightness to 0. Color correction brightness to minus 0.75. And color correction saturation to 1. Set the color correction tint color to blue and contrast to minus 20 to get this effect for a split second. And let's talk about field of view. So, my default is 70. I'm going to set it to 45 right now and add 5 to it 5 times, so it gets back to 70. If you have higher field of view than 70, you might want to increase it by 6 or 7. You get the point. So, set the hue shift to true, offset to 0.5 or whatever you like. Loop through the first effects folder, set main cuts transparency to 1 and RGB ones to 0. Wait 0.05 seconds, set contrast back to 1 and tint color back to white. Check if a local character inside of our table and increase field of view a little. Decrease offset, loop through the children of the first effects folder. Set red cut C-frame to main cut C-frame multiplied by C-frame.new, offset 0, 0. And blue one to main cut C-frame multiplied by C-frame.new minus offset 0, 0. Do the same for circular cuts, and after that it's basically just copy paste. So wait 0.05 seconds, increase field of view, decrease offset, and once your offset gets to 0.1, instead of setting it to 0, flip the transparency and start over like this. Do that again, and that would finally be the end of the fourth event. And on to the fifth we are. This one happens just a little bit before the sixth one, so we can have some time when cuts no longer spawn, but didn't disappear yet. So, unbind the cuts function, check for local character, unbind camera glass function, and twin color correction saturation to -1. This will make everything gray. Loop through the first effects folder, and twin all of the judgment cuts, transparency to 1. And before we continue to the sixth event, let's make this electricity trail effect. So, first open up a Blender, go to Edit, Preferences, get extensions, search for the thing called IVGen and install it. After that, go to add-ons, find it here and make sure it's enabled. Click on this little gray thing, go to create tab and here it is. Originally this add-on was meant to generate IVs and stuff, but we're gonna get a little creative. So these are the settings you pretty much gonna use. Feel free to play with them a little until you get what you want. But I should mention that to get different results, you need to change the random seed property, or it will just give you the same thing over and over. Also, for some reason to create IVs, you have to first click on a mesh. I don't know why, but just keep that in mind. Now arrange these IVs in a trail like this. Actually make it a couple times to create illusion of it moving. Not gonna lie, I did a pretty bad job here, but it should be enough for a showcase, so you know how to improve it. After you're done, select all of your trails. I'll show on these ones. Right click, convert to mesh. This will convert all of that from just lines to actual geometry. But if you look close enough, you can see that there is a hole at the end of each brand. To fix this, go to edit mode, select everything by pressing A and press F to fill holes. And the last problem is that we have too many polygons to import it to Studio. So add a decimate modifier to one of your IVs. Go to collapse and drag the ratio bar to the left, and you need to stop right where it starts to get too deformed. I'll keep it at 0.3. Now select all of your IVs and make sure the last one you selected is the one you added a decimate modifier to. You can check this by the brighter color than other selected objects. Press Ctrl L and select copy modifiers. You don't have to apply them, so it's time to export. So if you want to export with OBJ, select each trail and export them separately. And if you want to use FBX, select all of the IVs in each trail and hit Ctrl G to join all of the IVs together. After that, you can just export all of the trails together. Once you imported all of your trails, set their position to one of your animating dummy humanoid root part and offset it until it's at the right position. Remember by how much you offset it for later. Back to the script, clone first trail, clone your first electricity trail and ground marks before getting to the 6th event. This happens when your character falls down from the sky and becomes visible again. So, destroy the first effects folder, check for the local character, twin bloom intensity to default, lightning brightness to 3 or whatever your default is, color correction brightness to default, and contrast to default as well. Rotate the character by 180 degrees so it's facing the other direction. Set the C-frame of the electricity trail to character's primary part and offset it by whatever you've written down from before. Parent it to workspace.fx. Now to the ground marks. If you didn't guess already, I just took 2 ground marks that we already had and offset them just like we did the electricity tail to give them a unique look like that. After you did exactly that, loop through the descendants of our character, check if it is a base part, if its name isn't collision part or humanoid root part, and check the tag for any additional parts that should stay invisible. And set the transparency of whatever left to 0. I guess if you have decals that should be invisible, you can use tags for them as well. The 7th event happens right when your character begins to sheath the Yamato. So, loop through the 2nd effects folder, find all of the glass, and twin its size X to 0. Keep the rest the same. Also, it would be great if you twin transparency a little bit. 2. The time of the twins should be just enough for the character to sheath the Yamato, so right until the 8th event. And finally the 8th event, that happens when your character sheaths Yamato. So, create a new model, create a for loop, go to Blender again. Now we're making some glass shards. So get your cube, delete the back of it, so only one face left, scale it a little bit by pressing S. And the easiest way for you to do this is probably going to be knife, which you can get by pressing K if you already forgot. So, cut some shapes like this. These are the ones that I made. After you're done, go to edit mode, select everything with A, and extrude with E to give them some depth. And Studio Engine can recognize them as a mesh. Export, import, set material to glass, and we aren't using highlight bug this time, so set transparency to something like 0.3 or whatever. Anchor it, turn off can collide, put them inside of the replicated storage, use math.random to randomize the shard that we're cloning, and use the same formula that we used for the breeze here. Oh, and parent the shards to the model that we made. Go back to Blender, I swear it's the last time, get a cube, delete one of its faces, add a mirror modifier, enable it on 2 of the axes, set the Y position of these vertices to 0, and set Z position of these vertices to 0 as well, like this. Now arrange your vertices something like this. Delete this face, delete this edge, hit E to extrude from these vertices like this, lower this one a little bit. Now apply the mirror modifier, select all of the vertices with A, hit F, extrude, export, import, anchor it, turn off collision, make it neon, and also what I actually did is cloned it, scaled a little bit like this. Made smaller one white and bigger one blue. Put a smaller one inside of the bigger one and weld them together with wheel constraint. Put it inside of the replicated storage, clone it, parent it to the sheath of the Yamato, set its C-frame to sheath attachment world C-frame position inside of the sheath, looking towards to the camera C-frame dot position. Rotate it if you need and offset it a bit so it renders on top of the sheath just like a particle with Z offset would. Use game.debris to delete our spark. Create a new instance point light inside of the sheath attachment, color it, set the brightness to something like 40, range to something like 15, use game.debris to delete it, play the final part of the audio, average the mass of the glass shards the same way we already did with the breeze. Preferably make the mass of the glass shards equal to the mass of the debris. Loop through the glass shards model, create a new instance attachment inside of each shard, and a vector force inside of each attachment. Set vector force attachment 0 to our attachment, and vector force relative to enum actuator relative to world. Assign a random.new and set vector force to vector3.new 0 random next number, and I have numbers here for 0.005 mass. If you have a different mass, you would need to figure out how much force to apply yourself. And 0. Use game.debris to delete the glass shards model after a few seconds and unanchor the glass shards if you didn't already. Loop through the debris model and do the same thing we just did with glass shards. Though I would recommend to set the force a bit higher so the debris falls slow. Destroy the second effects folder, check for the local character again and set the color correction saturation to 0. Wait a bit, destroy the first electricity trail and clone the second one. Do that until you run out of the trails. After that, check for local character again and set the bloom threshold back to default. Wait a few seconds and twin the fade out of these ground marks and delete them after that. Alright, before I finish this off with ServerScript, let me explain where you can get the audio. So, first option is just make it from scratch, but probably that's not what you want. So, another option is try searching it on Roblox Creator Store like this and download it either with better Roblox plugin or through the admin panel. Alternatively, you can try searching on YouTube or free audio libraries. Also, it will be much easier to find versions with voice lines than without, so keep that in mind if you want to voice it yourself like I did. And I also recommend you to split your sound in 3 parts like this. So it will be easier to adjust to your animation. Okay, back to the server script. Assign a desired cooldown and a bool value for it. Check if it's false and set it to true if it is. Subtract the time we passed through the local script from the current server time to synchronize our server script with a local one we just finished. Set the character humanoid walk speed to 0 and jump height to 0. Wait another 1.75 seconds until the slashes start. Create a new hitbox with your preferred method. You can learn what methods there are in my previous video. I'm going to use get part bounce in radius with sphere position and its radius. Create an empty table and loop through all of the detected parts. Check if a part has a parent, check if it has a humanoid inside of its parent, and make sure its parent isn't inside of our table yet. Add it to our table, set the character's humanoid walk speed and jump height to 0, anchor its primary part. Here you also can add things like stun if you want. Wait until the character sheaths Yamato, loop through our table, unanchor the primary part of everybody that inside of our table, decrease their health, wait until the animation finishes playing, set our character's humanoid walk speed and jump height back to default, wait cooldown minus the time we got from client minus all the time we already waited, and set the CD to false. Alright. From now on, I expect every judgment cut end on Roblox to be at least this good. Hopefully, I was able to teach you one thing or another. Comment what would you like to see next. Would also appreciate if somebody could better explain math parts of the video. Consider joining my Discord server. Leave me a like if you have some to spare. Stay motivated. And goodbye. Finally, a video I could be proud of. Still could have done some things better though.